Hey, good day, everyone. Welcome to DevOps 101. And my name is Anand. And my promise to you today is in the next 15 minutes, you're going to be better than at least 90% of the people when it comes to understanding of DevOps. Because you're going to take away the foundation of DevOps and the power of automation behind DevOps. And also, you're going to see how the anti DevOps pattern used to be like 15 years ago or so, and still continues to happen in a lot of organizations. And finally, I'm going to demonstrate to you the power of tools like GitHub and Azure on how you can implement DevOps when it comes to automation. Before jumping in, a few prerequisites to this video is I'm going to assume that you have some basic knowledge on code repositories such as Git, SVN, things like that, or Bitbucket. And you have written some basic code in any language, as basic code would do. It doesn't matter whether it's C Sharp or Java or Python. And also you understand some basic about software development processes such as development, testing, etc. Even theoretically, it's fine. And before we proceed further, I would like to introduce myself better so that you can be confident that all these information that you're getting is from a qualified person. So after completing my Master of Science in Oxford Brookes University in 2004, I was a developer for 5 years, worked around organizations like IBM and Nokia, and then slowly migrated into quality assurance side of things, where I was there for 7 years and finally ended up as a QA lead in Mailgut, where I set up a lot of processes in QA testing automation, including some of the DevOps processes, which led me to a dedicated career in DevOps, where in Suncorp I was a principal DevOps engineer for 4 years before I got promoted to a DevOps chapter lead, where I served there for 2 years. And currently, I'm a co-founder and CDO of a startup named Apodi, where we are working towards using AI, making home buying the best experience ever. So that's me in a nutshell. And as you can see, I've been through development, testing, and DevOps, and I've been in enterprise and startups. So I'm sure the information you're going to get today is of quality one. All right. So in a traditional, when I say traditional, going back to a few years, or even happens, as I said before, in some organizations with less maturity, where DevOps, the term, the developers and the operations teams are not operating in sync or they're not collaborating. Where traditionally developers develop and operations teams deploy the code to production. So take a simple requirement such as writing a simple Python script. Right? So the developers develop the code locally, they test locally, and once they're happy, they hand it over to operations. Then operations take it and deploy and manage in production. That's how the traditional DevOps used to work. So just as an example to show you how this will happen in the real world, if you haven't had any real-time experience. So I've written a small hello world.app.py Python script, which does nothing. It says hello world and uses, without going too much into details, it uses a library called Flask to run an application. And I've got a small unit test. So unit test is basically to test whether the piece of development that you have run, that you've written, is good enough and it's working as expected. Right. And when you run an application, when you run the application, so if I run 3 hello world.py, there you go. You can see that application is running on my local host and port. And it looks something like this. I'll refresh it for you. It says hello world. That's it. So all I've done is I've written an application. I've mentioned that you need Flask as an application. I've run the Python script. The unit test is working fine, which I haven't shown you yet, which I'll quickly show you. So if we run something called py test, hello world of py, unit test is passed, which is all good. What I do now, I hand it over to operations for deployment into production. Now, what you see here is the wall of confusion between the developer and operations. Now, as a developer, it's clear, like I had a library that I need to install on my local machine, and I just need to run Python 3. I need to run unit test, which I've run, obviously, and I've given it to operations. From operations perspective, just confused. There's a lot of confusion, right, when you handle an application like that. So they have questions like, what version of Python do you want to run this on? As you saw in my video, in my earlier screen, so if I do Python version, it's 3.11.4. That's the version I've developed in, so which I haven't specified in the documentation, right? What version of the Flask library that I need to use? That's something I haven't specified. So the latest library could actually break the code, or old library could actually break the code. And we don't know as an operations guy whether the developer has developed this based on a specific library version. What port is the application running on? I've just assumed an automatic port of 5000, which is where the Flask application runs, but I've not specified it in this case. What operating system should I run this server on in production? Should it run on Linux or Windows or Mac, where I've developed it? And what is the expected load of this service? Is this service going to be handling like 1000 requests per minute? Or it's going to be 20 requests per minute? Because this will determine the infrastructure requirements for this app to service the customers of this Hello World product. Of course, it's a bit of an example here, but you can imagine if there is added functionality there. Those are the things that the operations team is heavily confused about in a traditional approach to software development in an anti-DevOps pattern. And imagine you deploy the application, somehow magically everything runs fine. And suddenly there's a bug and you got to fix it. It comes back to developer fixes it and hands it over back to the operations guy. And the operations person doesn't know what the bug fix is, right? So there's a lot of things that's missing in an old way to software development. Right? The end result, of course, it's a poor customer experience as a result of delays in development, because operations is going to go and ask developers, hey, why is this not here? What am I supposed to do, right? As you saw, whether it's in Windows or Linux application. There's going to be a lack of trust now every time between an operations team and a development team. Not only that, and stakeholders as well is going to be worried every time we push a release out. This is also going to result in a lot of unstable production code, right? So you don't know like how to configure an application, right? In this case, as an example. And of course, with all these confusion, there's increasing cost. And as I said, it's going to result in a poor customer experience. Now, if we apply a DevOps kind of an approach to automation, right? When I say DevOps approach, as you saw earlier, there was lack of collaboration. Now both the people are collaborating here. Both the teams are collaborating for the same Python script, a simple script. So in this case, what happens is a developer develops code, yeah, which I've shown you earlier. After you run and test locally, yeah, absolutely fine. But then something interesting happens after that, because a developer actually tests the deployment on a fresh environment, such as a development environment from the scratch. And they also deploy to a pre-prod like environment where the specifications of the infrastructure, this is memory or the hard disk, and all other configurations that you need to specify for a production-like infrastructure is also being tested. And once it's tested, both by the devs and of course QAs are going to get involved at this stage. The dev and ops collaborate together when deploying things to production. And of course, because operations is the heart of the production environment, or they manage production mostly. So they're going to be the ones who's going to have access and rights in big enterprise applications due to the heavy nature of industries such as insurance or finance, etc. So with that, let me introduce you how this is going to work, right? So I'm going to introduce a term called continuous integration here, where just to take you previously, a developer develops a code, right? He also wants to add another piece of code, right? So which means I have to continually integrate my new code and deploy it to a production-like environment. So that's the goal here, right? So in this case, continuous integration is every bit of code I write needs to be stored somewhere so that it's got all my latest updates and also being tested. So the important thing to note in continuous integration is stakeholders or developers, right? And the process that's important in this phase is build of the code happens, right? And the unit test or run. And just I forgot to mention previously as well, by automating all these steps, such as running on environments, testing it first in an environment, running it on a development environment, etc., you provide a lot of credibility to that system so that you can confidently integrate code, assuming that assuming that with more confidence is if you have introduced an error and unit test will catch it, you will know it immediately. Right, so coming back to continuous integration, stakeholders are developers and they build and test. So I'm going to show you how continuous integration happens in this case, right? So firstly, let's go to GitHub quickly. I'll show you what GitHub is. If you haven't used GitHub, there is cloud-based repository, where you store your code. Right. So in this case, the hello world app.py, hello world test.py, those are all stored here. And it's free basically. So for free accounts, I've created a free account for myself. So you can create a free account. Yeah, you can start committing code to this one. So let's just to give you a bit of an introduction. So if I'm going to test, right, hello world.py, and then I'm going to, for some reason, the requirement now changed that the script should return hello world 1 instead of hello world, right? And now I wanted to commit this change. Right, before committing, let's also ensure that the script is working fine. Hello world.py, sorry, hello world.py, and now the test is running. Sorry, the script is running. So hello world 1, that works, right? Everything is good. So there's a change. Now I'm going to quickly deploy this change to hello world 1. Oops. Sorry, it's the wrong part. So I'll go to hello world.py, change it to hello world 1, and git commit -a -m, change hello world 1. It's just a meaningful commit message, and I push it. So once I push the code, you should be able to see the latest code appearing here. So if you look at this hello world.py, it's got hello world 1 here. All right. So once I've committed the code, I said as part of this continuous integration where you build the code, right? So there's something called GitHub Actions that I've already configured. So it's easily configurable, and it's basically a YAML file. I wouldn't go too much deep into this one, but you can always add any kind of um, job. So I'll show you the YAML file here. So if you look at this YAML file, basically what I mentioned in the YAML file is that on push to the branch main, which is the branch I'm working on, you on an Ubuntu latest machine, I've said that run on Python 3.10, it's fine. And I run a few pip install commands. Of course, Flask come by default, so I don't need to mention it in this case. But if I need to, in external libraries, I need to mention here. And I want to run py test. This is where the unit test runs. So because since I committed right now, my build has failed. And the reason it failed is, there you go. It's the unit test says it wants to see hello world, but it saw hello world 1. That's why the test failed, because we committed the code. However, we didn't fix the unit test now, right? So we have basically shifted left on fixing an error in application even before we go to the operations team, right? Or even before we hand it over to a separate team to test, or even before we actually deploy the code, a buggy code. All right, now as a developer, what I'm going to do, I'm going to fix the unit test, right? As you can see, there's hello world here, and I want to run it to hello world 1. And now if you actually, I'm going to quickly show you that I skipped the process here intentionally, because if I had run the unit test, it would say that one test failed, right? So I didn't do it intentionally to show you this power of continuous integration. Now, if I run the unit test, oh good, it passed. So I'm going to do a git commit, fix unit test, push. Awesome. So now you should see a build to be triggered. So you should see something building. Go to actions again. See, there you go. The fixed unit test is coming. I'll show you the build output as well. As you can see, GitHub has done an awesome thing. So there you go. It does a lot of pip install. Now it runs py test. The py test is passed. Now it's run. So the build is green now. So basically what I've done is we have continuously integrated the code. And let's say that another developer is also working for parts of this repository. He or she can also push the code. So which means developer 1, developer 2, developer 3 are all continuously integrated to one branch, which is being tested unit test wise at this stage as a part of continuous integration process. Right. Now to get this, a couple of things I wanted to mention. So you need to ensure that you add your SSH keys to your GitHub account so that you can push like this. If you don't have SSH keys, you can refer to this part here. Just to show you what I mean, if you go to GitHub's and settings and deploy keys, you can see the my key for SSH I created for this video is added. Right, and if you actually see in my system as well, my key is added here, Academy. So that's the key I'm using to push code to GitHub. So make sure that you do all these things, and of course push and commit initial code. That's the step we do.